Welcome to The Explainer. You know, we love to break down complex topics into really clear, understandable journeys. And today, we're going to follow a machine learning model from its very first line of code all the way to a customer-facing app. And we're going to use the Databricks platform as our guide.
But first, let's start with a really big question, one that I'm sure many of us in this field have bumped up against. Why do so many machine learning projects, after showing all this amazing promise in a notebook, just fail to ever make it to production? You know that gap between a great experiment and a real-world application? It's often just a messy, chaotic chasm. So, to bridge that gap, we're going to follow our model's journey across these 5 key stages. We'll start with the whole MLOps philosophy, then we'll see how to accelerate development, build on a solid data foundation with a feature store, track our progress with ML Flow, and then finally, guide our model all the way into production. Okay, let's dive right in. The solution to all that production chaos is MLOps, which stands for Machine Learning Operations. And really, you can just think of it as turning the unpredictable, kind of artistic process of model building into a repeatable, reliable assembly line. Now, MLOps isn't just one single tool. It's more of a philosophy, a set of best practices. And the core idea? It's simple, but it is so powerful. Treat your machine learning assets, your code, your data, your models, with the same discipline as traditional software. And that means having separate environments for safety, versioning absolutely everything so it's reproducible, and automating your pipelines for reliability. So before our model is even a single line of code, we can actually set it up for success. The journey to production really starts by speeding up the development phase itself. You know, one of the biggest time sinks for any data scientist is just getting the environment right. ML runtimes totally solve this by acting like a pre-packaged toolkit. With literally one click, you get a consistent, optimized environment where everything just works. This frees you up to focus on what actually matters, which is building great models, not fighting with dependencies. And what if you want an even bigger head start? Well, there's AutoML. It's designed to handle that initial, often really tedious trial and error part of building a model. It basically creates a high-quality baseline for you. So here's the crucial point. AutoML doesn't just hand you some black box model and say good luck. No, it gives you the full source code in a notebook. Along with all these great insights like feature importance plots, this means you get a fantastic starting point that you can actually understand, trust, and then build on. Okay, let's keep building here. A model is only as good as the data it learns from, right? A feature store acts as this central library, making sure that every single model is learning from consistent, high-quality, and up-to-date information. It's a single source of truth. And what's really fascinating is how this has evolved. The old way was siloed. Your features were basically trapped inside a single project. But the modern approach, using a unified governance layer like Unity Catalog, completely transforms features into shared enterprise-wide assets. And just like that, the work of one team can accelerate the work of every other team. No more reinventing the wheel. The workflow is actually beautifully simple. You create a table, you write your data to it, you build a training set, and then you train your model. This structured process is designed to prevent one of the biggest reasons models fail in the real world: training serving skew. That's just a fancy way of saying the features your model was trained on look different from the live data it sees in production, which causes its performance to just totally collapse. A feature store makes sure everything is consistent from day one. So as our model starts to take shape, we're not just building one version, we're running dozens, maybe hundreds of experiments. This is where ML Flow comes in. It acts as our digital lab notebook, meticulously recording everything so we never lose track of what actually works. I mean, just imagine trying to recreate your best result from 2 weeks ago. What were the exact parameters? Which version of the data did you use? ML Flow automatically captures all of it: the parameters, the performance metrics, the output files, even the exact source code. It's perfect reproducibility, which means no more, well, it worked on my machine mysteries. Okay, so once we have a model we're happy with, we hit this key strategic choice. Do we promote the code and then retrain it in the production environment? This is awesome for automated retraining pipelines and data security. Or do we promote the saved model file itself? This is usually the better choice for models that are incredibly expensive or time-consuming to train. Think of those huge deep learning models. All right, the moment of truth has arrived. Our model has been developed, tracked, and registered. It is time for it to graduate from the lab and get a real job
actually delivering value out in a production environment.
But this is a high-stakes moment. You can't just flip a switch and hope for the best. So how do you swap out a live, running production model without causing any disruption at all? Well, this is where a champion/challenger approach is an absolute game changer.
And the solution here is so elegant. You just use simple labels or aliases. Your live model is the champion. Your new, shiny model is the challenger. When you're ready to go live, you don't have to redeploy a single thing. You just reassign the champion label to the new version. The switch is instantaneous. We're talking zero downtime. It's a promotion, not some risky replacement. The kind of job our model gets really depends entirely on the business need. It could be a batch processor that just crunches numbers overnight, maybe a real-time API endpoint that powers live recommendations, or even a streaming analyst that's constantly monitoring for anomalies in a flow of data. For so many modern applications, real-time serving is really the holy grail. This is what enables those incredible interactive user experiences, like instant fraud detection on a credit card transaction, or that personalized content that appears the second you load a web page. And you can even de-risk the deployment of a new model even further. By splitting your live traffic, you can send, say, 10% of requests to your new challenger model and compare its real-world performance against the champion before you commit to a full rollout. It is the ultimate safety net. So, our model is live, it's working, it's delivering value. Is the journey over? Not even close. In a true MLOps culture, this is where the real work begins. Because the world changes, data drifts, and model performance degrades over time. The life cycle is a continuous loop of monitoring, retraining, and redeploying. It's a commitment to making sure our model doesn't just work today, but that it stays relevant and valuable for the long haul.